Hi, we are going to perform operations with rational expressions, and a rational expression is a fraction. So first we want to simplify, multiply, and divide rational expressions. So let's just try simplifying without any variables and say we have 64 over 160. So what we want to do when we simplify a fraction is try to break it down into factors, and I'm actually trying to think of the biggest factor that goes into 64 and 160, and that's 32. So I'm going to break down 64 to be 32 times 2, and 160 is 32 times 5. And then when you divide 32 divided by 32, you divide a number by itself, that just equals 1. So now I have 2 over 5, and then that's my answer. And I could have done that differently. Maybe I didn't recognize that 32 was a factor of both of those numbers, and maybe instead I did, I knew that they were both divisible by 2, for example. So I could have done 2 times 32, and then I know that 2 times 80 is 160. 2 divided by 2 is just 1. And I would have gotten 32 over 80, and then continued to keep simplifying until I finally got 2 over 5. So I could have done it differently, but we're just reviewing how to simplify a fraction. You break it down into factors, into things that multiply to get the numbers in the numerator and denominator so that you could cancel factors out, because when you divide a factor by itself, you just get 1. Okay, so now we want to try with variables. In order to simplify, we need to break down the numerator and denominator into factors, just like we just did in the previous problem. So I need to factor the numerator, x squared minus 7x plus 12. And I'm thinking of two numbers that multiply to get 12 and add to get negative 7. And that's negative 4 and negative 3. And when it's just a 1x squared, I could just plug those numbers straight into my factors. So now I've factored the numerator, and I also want to factor the denominator. So now I need two numbers that multiply to get 6 and add to get negative 5. That would be negative 2 and negative 3. So now I'm looking for common factors in the numerator and denominator that when you divide them, they just equal 1. So x minus 3 divided by x minus 3 just equals 1. And then what I have left is here, x minus 4 over x minus 2. We're going to keep going and try multiplying and dividing, and it's going to be the same idea. We always want to factor first and then see if we can divide common factors. Okay, so we're going to multiply this first fraction together, and there's not really anything we need to factor for this. We don't have separate terms like we do in number 4 that we did in the previous problem. So actually I'm just going to go ahead, and there's two ways we could do this. We could just go ahead and multiply the numerators together, and then multiply the denominators together, and then simplify. So I'm going to try that method first. So if we have 5x squared times 6xy cubed, that's 30 x cubed y cubed, and then I'm going to multiply the denominators together. 2xy squared times 10y, 20xy cubed. So now I can try to figure out what I can divide in the numerator and denominator to simplify. So for example, if I just look at the coefficients 30 and 20 and just simplify 30 over 20, that would be 3 over 2. X cubed divided by x, so now I'm kind of looking at like terms. X cubed divided by x, if I cancel out that one x in the bottom with one of the x's in the numerator, then now I have x squared in the numerator. And then y cubed divided by y cubed is just 1, so then I don't have any more y's. So now my answer would be 3 in the numerator, and I have an x squared in the numerator, and then the denominator, just 2 left. Another way I could have done that was to simplify first before I multiply the numerator and denominator together. Because they're going to end up multiplying them anyway, I may as well leave them as separate factors. And then I can look at anything in the numerator that can cancel out with anything in the denominator. For example, 5 and 10, 5 over 10 is 1/2. I could take 6 over 2, 6 divided by 2 is 3 over 1. I can look at the x's, x squared divided by x. We just end up with an x in the numerator. I could do y squared and y cubed and get a y up here. So it might be helpful to try to simplify some stuff first. I'm just going to go ahead and start writing what I have left because now I've crossed out a bunch of stuff. So I'm looking at my numerator and I have a 3. I have an x here. I still also have this x here. So since I'm multiplying, this is a multiplication problem, now I have x squared, and then I still have a y in the numerator. And in the denominator, I'm seeing I have a 2 here, and then I also have this y. And then I'm double checking I still actually have things that I can simplify. So y divided by y is just 1, and then I'm ending up with the same thing that I got down here, 3x squared over 2. So you can try to simplify some things first, and then just double check and make sure that you have simplified everything that you can. And like in this case, I still had y, so that could be simplified. Okay, number 4 is a little bit different. We need to factor first. So anytime there's separate terms, like here, 2x plus 6, anytime there's separate terms in the numerators and denominators, we want to break those down into factors, and then we can start seeing if there are common factors in the numerator and denominator that could be canceled out. So 2x plus 6, I can factor out a 2. 2 times x plus 3. In this denominator, I'm going to break that down. It's a quadratic, so I'm thinking of two numbers that multiply to get -6 and add to get 1. 3 and -2, x plus 3, x minus 2. And then I'm multiplying that whole thing by this fraction. So I'm looking at the numerator, x squared minus 4. That's a difference of squares, x plus 2, x minus 2. So that's one of those special factoring ones, a difference of squares. And then 2x in the denominator is just 2x, it can't be simplified. So rather than multiplying everything in the numerator together and then everything in the denominator together, I'm going to stop there, and then I'm going to check and see if there's anything in any numerator that can cancel out with anything in the denominator. So I have x plus 3 divided by x plus 3, x minus 2 divided by x minus 2, 2 divided by 2, and then I'm going to go ahead and write what I have left. I have an x plus 2 in the numerator, and in the denominator, x. Let's look at what happens when you're dividing instead of multiplying. Remember, when you divide by a fraction, you can change that to multiplying by the reciprocal. So dividing is the same thing as multiplying by the reciprocal. So I'm just going to rewrite this as 3x squared over 5y times the reciprocal of this second fraction, 10y cubed over 9x. And now I'm going to try to see if there's anything that I can simplify before I just multiply numerators together and denominators together. So I'm looking at the numbers first. 3 over 9 is 1/3. 10 divided by 5 is 2 over 1. I have an x squared divided by x, which means I still have an x in the numerator. And then y cubed divided by y leaves me with y squared. Okay, so I'm looking at the numerator. I have an x, a 2, and a y squared. 2xy squared. We usually write the number in the front. And then in the denominator, a 3. 3. So there was nothing to factor in that one first. In number 6, we're going to need to factor first. I'm seeing separate terms, and we need to break those down into factors. So in this first numerator, and actually, before I do that, I'm going to rewrite it. 6x squared plus x minus 15 over 4x squared times, so just like the last one, we can change the division to multiplying by the reciprocal. So the reciprocal of a number that's not really in a fraction, you could put it over 1 and then we flip it over. Okay, so now I'm going to factor. In this first numerator, I'm going to factor this up here. We have a number in front of the x squared, so we multiply that value 6 times negative 15, and I'm trying to think of, when I think of my two numbers, I'm trying to make them become that product. So 6 times 15, or 6 times negative 15, negative 90, and then in the bottom I'm going to put 1 because there's a 1x, and now I'm thinking of two numbers that multiply to get negative 90 and add to get 1. So since this is a 6x squared, not a 1x squared, I can't just jump straight to making it x plus 10, x minus 9. I'm going to do the area model. I'm going to put the first term in the first box, 6x squared, last term in the last box, negative 15, and then these numbers I just came up with are going to go here, but with x's on them. And then I'm going to look through the rows and columns and factor like terms out. This 4x squared is just 4x squared. There's nothing I could factor with that. 1 is just 1. And then 3x squared plus 5x, there is an x that they have in common. So I'm going to factor out an x. 3x plus 5. And again, before I multiply the numerators together and the denominators together, I can start canceling out anything that's in common in the numerator that's going to be divided by the same thing in the denominator. So 3x plus 5 divided by 3x plus 5 is just 1. And I don't see anything else. So in the numerator, I still have 2x plus 3 times 1. So just 2x plus 3. And then in the denominator, 4x squared times x. So 4x cubed. The next part is adding and subtracting rational expressions, which is a little bit different. When you add and subtract, you need a common denominator. These first couple already have a common denominator. So when you have a common denominator, you add the numerators together and the denominator stays the same. So 5 plus 3, 8. And then always make sure you want to see if you can simplify that. I can rewrite this as 4 times 2 and 4 times 3. And then 4 divided by 4 is just 1. So I get 2/3. So if you already have a common denominator, you add the numerators together and then the denominator stays the same. So same thing with number 2. The denominators are already the same, x squared minus 4. So I'm going to go ahead and add these numerators together. They're not like terms, so it would just be 3x squared plus 6x. The denominators stay the same, x squared minus 4. But just like the last problem, once I've added the two fractions together, I want to see if I can simplify anything. So in the numerator, I can factor out a 3x. I'll have x plus 2. And then the denominator, this is another difference of squares. X plus 2 times x minus 2. X plus 2 over x plus 2 cancels out. And I end up with 3x over x minus 2. So now we have some where we don't have a common denominator. We want to rewrite the denominators so that they're the same value. One way to do that is to break down the denominators into prime factors. So if I think of numbers that multiply to get 12, for example, 4 times 3, and then I could still break down the 4 to be 2 times 2, and then 2 and 2 and 3 are prime numbers. I can't break those down anymore. So now I can write that there's 2 times 2 times 3 equals 12. I'm going to write that as 2 squared times 3. And then I could do the same thing with 16. 4 times 4 is 16. I could break down these 4's into 2 times 2. 2 is a prime number, so I can't keep going. So 2 to the 4th is 16. And then I can take, I want each of the prime factors that I have listed. So I have a 2, and if you have different ones, you want the one with the highest power. So 2 to the 4th. And then I have a 3, so I want to include the 3. 2 to the 4th is 16, and 16 times 3 is 48. So the common denominator is 48. Another way to do that is to just try to think of multiples of 12. So 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, and so on. And then try to think of numbers, multiples of 16. So 16 times 1 is 16, 16 times 2 is 32, 16 times 3 is 48, and then say, hey, these are in common, so 48 is my common denominator. So if I want to rewrite each of these as a denominator of 48, I have to think of how did I go from, for example, 12 to 48? What do you have to multiply 12 by to get 48? Well, I just did that here. It was 12 times 4 is 48. So then I need to multiply the same number in the numerator and do 5 times 4 and get 20 for the numerator. 16 times something is 48. I just did that here. It's 3. So then I need to multiply the numerator by the same number. 3 times 3 is 9. Now these have common denominators, and I could add them together and get 29 over 48. That cannot be simplified anymore. 29 is actually a prime number, so you can't even break it down. So just 29 over 48. That was with no variables. I just wanted to review how to just add fractions that don't have a common denominator. So now in 4, same idea. Now we have a variable there. So if I just kind of ignore the x and think of a common denominator for 4 and 7. So this lowest number that 4 and 7 go into is 28, but because this denominator has an x in it, I need to include that, and the other denominator is going to need to have an x. So 28x is my common denominator. Now I'm thinking of what would I multiply 4x by to get 28x? It would be times 7. So I need to multiply the numerator by 7 as well. 3 times 7 is 21. And then I'm thinking, what did I multiply? What do I multiply 7 by to get 28? That would be 4x. So in the numerator, I need to multiply by 4x. Now these have common denominators, and I can add them together. I just add the numerator together, and I leave the denominator the same. The numerators aren't like terms, so I just have to write it as 21 minus 4x, and then 28x in the denominator. I cannot factor 21 minus 4x, so there's nothing that I can even try to simplify. It's just 21 minus 4x over 28x. We're going to keep going and try a couple more where we're trying to rewrite the denominator so that they're the same. All right, these denominators are a little bit different because they need to be factored first before we can get a common denominator. In the previous problems, it was just a 4x and a 7. There's nothing I could factor with those. But I'm seeing, for example, in here, 3x squared plus 3x, that could be factored. You could factor out a 3x and get x plus 1. Okay, let me rewrite what we have. I can't factor 9x squared or the 7 on top, so that just stays the same. And then I'm going to put the other one now with the factored denominator. Okay, to get a common denominator, I'm going to look at the numbers first, 9 and 3. I'm ignoring like the variable part of the factor. So 9 and 3, to get a common denominator, that's 9. That means I would need to multiply the 3 by 3 to make that a 9. So now both denominators would have a 9 in them. But because I multiply the denominator by 3 on the second fraction, I would also need to multiply the numerator by 3. So now I'm looking back at the denominators. Now they both have a 9. This one has an x squared. This one only has an x. So that means I need to multiply the second denominator by another x so that it will have an x squared. I'm ignoring the x plus 1. That's a separate factor. That doesn't count as making it an x squared. Because I just wrote x in the denominator here, I need to also multiply the numerator by x. So now I'm looking back at the denominators. They both have a 9. They both have an x squared. But this one has an x plus 1. The second one has an x plus 1. That means the first one also needs an x plus 1. So I'm going to multiply this first denominator by x plus 1. And I would also have to multiply it by the numerator. So now each denominator has a 9. I'm going to start writing that out. They both have a 9. 3 times 3 is 9. They both have an x squared. That's x times x is x squared. And then they both have an x plus 1 now. And I need to rewrite the numerators. In this numerator, I have 7 times x plus 1. And I'm going to multiply that out. 7x plus 7. The denominators you want to leave factored, but the numerators we need to multiply out so that we can combine the numerators together. The second numerator, 3 times x is 3x squared. Okay, so now I have common denominators. I can add the numerators together. I'm going to write it in standard form. None of the terms in the numerators can be combined because they're not like terms, but I'm going to put the 3x squared first plus 7x plus 7 over, again, I'm just leaving the denominator factored because now we want to see if we can factor the numerator and then can't see if any factors can be canceled. So can we factor the numerator? I would need to multiply 3 times 7, 21 on top, 7 from the middle term on the bottom, and then I'm trying to think of two numbers that multiply to get 21 and add to get 7. 21 is just 1 times 21 and 3 times 7, so no, it's not possible. So then we just leave our answer like that. We don't need to keep going because we can't even factor the numerator. All right, on to number 6. Same thing, we want to factor first. So I'm looking at this first denominator, and I could factor it as, let's see, two numbers that multiply to get negative 12 and add to get negative 1. X minus 4 times x plus 3. And then 5 is just 5. Can't be factored. Even if the numerators could be factored, just leave them unfactored. I only want to factor the denominators so that we could get a common denominator. I could factor out a 12 and get x minus 4. Okay, both denominators already have an x minus 4. That's great. They have something in common. But this denominator has an x plus 3. That means the other one also needs an x plus 3. If I multiply it to the denominator, I also have to multiply it to the numerator. This denominator has an x minus 4. The other one already does. And then this denominator has a 12. So I need to multiply the first denominator by 12 and then also multiply it to the top. Okay, I'm going to write what I have now. In this numerator, the first numerator, I have 12x. Denominators do not multiply out. Leave factored. But numerators multiply out. So 5x plus 15, because I'm going to distribute this 5. And now I can combine like terms when I add the numerator. So 12x plus 5x, that's 17x, plus the 15. Again, I'm not going to multiply out the numerator because I want to see if I could factor, or I'm not going to multiply out the denominator. I want to see if I could factor the numerator to see if there's anything I could cancel out. But there's nothing that goes into 17 and 15. I can't factor the numerator. There's something left to simplify. So then that's my answer. All right, this last one, I'm a little tight on room, so I'm going to add another slide and do it on the next slide. Okay, so same thing, factor the denominators. Two numbers that multiply to get -8 and add to get -2, x minus 4, and x plus 2. And I need two numbers that multiply to get positive 32 and add to get -12, minus 8, x minus 4. So if I multiply -8 and -4, I get positive 32. If I add them, I get -12. Okay, they both have x minus 4. So I'm looking at the denominators, the bottoms, and I want to see what they already have in common. They already have x minus 4 and x minus 4, but this one has an x plus 2. So the other one needs an x plus 2. Whatever you multiply to the bottom, you have to multiply to the top. And then this has an x minus 8. That means this one needs an x minus 8. Okay, we multiply out the numerators so that we can add them. Denominators do not need to be multiplied out. I'm multiplying x plus 3 times x minus 8. Denominator, don't multiply it out. I'm multiplying x minus 5 times x plus 2. And now I can combine the numerators. This problem is subtraction. So I want to make sure I subtract this whole other numerator. I'm distributing the minus. So I have x squared minus x squared. No more x squared terms. I have negative 5x minus negative 3x. That would become negative 5x plus 3x, so negative 2x. And then negative 24 minus negative 10 would become negative 24 plus 10, so negative 14. Denominators just stay the same. And then final step is to factor anything that could still be factored, so I could see if I could cancel any common factors out. So in the numerator, I could take out an x or a negative 2 and have x plus 7, but there's not a negative 2 by itself or an x plus 7 as a factor in the denominator. So although I need to check to see if I can cancel out common factors by factoring, nothing could have been simplified. So this is our final answer, or you can leave it like this.